So, enhance your grasp. Linear programming exercise 1. A bakery manufactures two kinds of cookies, chocolate chip and caramel. The bakery forecasts the demand for at least 80 caramel and 120 chocolate chip cookies daily. Due to the limited ingredients and employees, the bakery can manufacture at most 120 caramel cookies and 140 chocolate chip cookies daily. To be profitable, the bakery must sell at least 240 cookies daily. Each chocolate chip cookie sold results in a profit of 0.75, and each caramel cookie produces 0.88 of profit. The question is A. How many chocolate chip and caramel cookies should be made daily to maximize the profit? And B. Compute the maximum revenue that can be generated in a day. So to go about this problem, we will have six different steps. Step 1. Identify the decision variables. Suppose the number of caramel cookies sold daily will be denoted as X, and the number of chocolate chip cookies sold daily will be denoted as Y. Now, step 2. Write the objective function. Since each chocolate chip cookie yields the profit of 0.75 and each caramel cookie produces a profit of 0.88, then we will write the objective function as p is equal to 0.88x plus 0.75y. Step 3. Identify the constraints. It was mentioned in the problem that the demand forecast of caramel cookies is at least 80, and the bakery cannot produce more than 120 caramel cookies. Therefore, we will write this constraint as 80 is less than or equal to x and is less than and equal to 120. Furthermore, it was also mentioned that the expected demand for the chocolate chip cookies is at least 120, and the bakery can produce no more than 140 cookies. Therefore, the second constraint is as follows: 120 is less than or equal to y, and y is less than or equal to 140. Lastly, it was also mentioned that to be profitable, the company must sell at least 240 cookies daily. Therefore, the third constraint is next slide. The third constraint is x plus y is greater than or equal to 240. Now, moving on to the next step, we must choose the method of solving the linear programming problem. As taught earlier, we will be using Desmos, which is a solution through a graphical method. Now we proceed to step 5. We must construct the graph and find the feasible region. We will now input the constraints we made earlier in the app Desmos in order to identify the feasible region. The constraints to input are as follows. Then, after inputting it in Desmos, it should then look like this. In the middle, the triangular area inside is the visible region. Now we proceed to step 6. Find the optimum point. To do this, we must test the vertices of the feasibility region to determine the optimal solution. The vertices we acquired from the graph are open parentheses 120 and 120 close parentheses. open parentheses 100 and 140, close parentheses, and open parentheses 120 and 140, close parentheses. To do this, we must substitute the acquired vertices to our objective function, which is, again, as we got from earlier, p is equal to 0.88x plus 0.75y. As you are wondering what the vertices are, as you can see at the image at the right, the vertices are at the edge where the red points are. Now, let's try it out, shall we? For 120 and 120, we just input it in x and y, and we get 195.6. For 100 and 140, we input it and we get 193. And for 120 and 140, we get 210.6. With this, for part A, it can be said that the bakery should manufacture 120 caramel cookies and 140 chocolate cookies daily in order to maximize profit. For part B, the answer is above. 210.6 is the maximum profit that can be attained in a day. That is all, and thank you for listening.